Okay, so for our next lesson, I'm going to give you guys two graphs. They're identical graphs, but on one of the graphs, we're going to put the graph for y equals negative 1/4 x plus 15. And the other one, we're going to graph 6x plus 24, y equals 360. So we'll have those for later on in this lesson. But today, we're starting 5.3. And let me get this set on slideshow. All right, so this is 5.3, sum of one, none of the other. And this is a solidify understanding task. It's a great task. Setting up the PowerPoint presentation was a little challenging because there's a lot going on. But you guys are going to do great, and I think this should go really well. So anyway, Carlos and Clarita are comparing strategies for writing equations of the boundary lines for the pet sitter constraints. They are discussing their work on the space constraint. So here's the space constraint. Okay, cat pens will require 6 square feet of space, while dog runs require 24 square feet. Carlos and Clarita have up to 300 square feet available in the storage shed for pens and runs, while still leaving enough room to move around the cages. And for this activity, they want to change things up. So we're going to change things up here, and what they did is this. They're just going to simply declare that x is the number of cats, or in this case this would be the number of cat pens, and y then would be the number of dogs, or in this case the number of dog runs. All right, so and we have taken statements like this constraint right here, and we have created inequalities in standard form pretty easily. So let's play with this a little bit. All right, cat pens will require 6 square feet of space. Well, x is the number of cat pens, so let's do a little inequality up here. We're going to go 6 times x, 6 square feet per cat pen, while dog runs require 24 square feet, so that would be plus 24y. And then Carlos and Clarita have up to, so up to, that means they can use less than or equal to, and that would be less than or equal to 360. And there you go. There's our inequality right there. And again, we've been working on this entire module. We're trying to be able to translate paragraphs into inequalities or equations. All right. Let's see how Carlos handled this. So Carlos is going to then, remember, how is he going to create a boundary line for this constraint right here? All right, so Carlos's method, I made a table. All right, so Carlos is going to do a table, and his table is actually going to have 3 columns. Okay, the first column will be x, which is going to represent the number of cat pens, and then y would represent the number of dog runs. And remember, they have up to 360 square feet, so whatever these add up to, when you plug them into this equation right up here, that inequality, okay, has to be less than or equal to 360 square feet. Okay, now let's see what Carlos did. If I don't have any cats, so Carlos will not need a cat run, or a cat pen I should say, then I have room for 15 dogs. Okay, there we go. And that 15 times this 24, because 24 times y is 360, that would have to give me a 360. So let's check this out. Okay, we have 0 cat pens, so 6 times x, 6 times 0, plus 24y is 360. Let's check his arithmetic. Let's take this 360 and divide it by the 24 to see if y does equal 15. So here we go. 360 divided by 24. Hey, the 15 works. So again, that's going to be exactly 360 square feet. Perfect. All right. And then Carlos did a little bit more arithmetic, and he said if I use some of the space for 4 cats, so he's going to have 4 cat pens, then he will have room for 14 dog runs. All right, and we could check that if we don't trust them, but that should come out to be 360 again. All right, then he said with 8 cats, I have room for 13 dogs, and that should come out with 360 one more time right there. Now, if you look at Carlos's table right here, I hope you can see a pattern. Do we see the pattern? All right, and I'm thinking the change in Y and the change in X. And in advanced mathematics, we write the change in our Y's as delta Y. You've seen me use that a few times before. But again, what is the change in Y? Well, the Y's are decreasing by 1, -1. What's the change in X? The X's are increasing by 4. Delta X equals 4. Now with that, I like to, if I'm going to complete this table, all right, and have a very useful model, I'm going to go down to the bottom. I'm going to say, what if I have no dogs, no dog runs at all? How many cat pens will I have? Well, Carlos would punch this out like this. He'd go, all right, well, 6 times the number of cat pens plus 24 times the number of dog runs has to be less than or equal to 360, or equal to 360 here. All right, and he has 0 dog runs right there. So how many X's? How many cats does he have room for here? Well, 6 times X is 360. So let's just go 360 divided by 6, and you guys would get 60. Now, let's use our pattern we saw above, okay? Except this time we're going to work up. So since my Y's were decreasing by 1, if I go to the bottom, my Y's would increase by 1. So that's a 1. Oh, and there's my 360. There's my 1. And let's see, the X's were increasing by 4. So from the bottom, they're going to decrease by 4. So that's a 56. And again, if I plug those numbers, X and Y, into my equation, I should get 360 again. And we'll check one before we're done here. So let's just keep this pattern going from the bottom. So I'd have a 2, and my X would be a 52, which would give me 360 square feet. Let's go 3, making my X over here a 48, and that would also give me 360 square feet. And I checked this one right here. So I took the 6 times my X, which is 48, plus the 24 times my Y, which is 3, and look at that, my calculator told me 360. So everything is working perfect. And then notice, I don't have room between X equals 8 and X equals 48 here for all of those ordered pairs, so I'm just going to go the pattern continues. Dot, 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 dot. And that's a perfect table right there. Now with this table, Carlos should be able to come up with an equation for the boundary line. So, the y-intercept. Well, you guys know when x equals 0, we have the y-intercept. So the y-intercept is a 15. All right, right there. And then what else do we need? The slope. All right, and hey, we better read what Carlos said. From my table, I know the y-intercept of my line is 15, and we see that right there with that ordered pair. When x equals 0, y equals 15. And the slope is -1/4. Well, let's talk about that slope. All right, now you guys remember slope is rise over run. And by the way, guess what rise is? It's the change in y, which is -1, because I'm dropping 1 every time. And what's the run? That's the change in x, which is 4. And look at what I'm doing. I'm increasing by 4 every time for my run. So the slope is -1/4. We agree with that. Okay? So Carlos gets y equals -1/4 x plus 15. He's using slope intercept right there. Y equals mx plus b. So Carlos did everything perfect there. So let's go ahead and take a look at Clarita's method right here. All right, so Clarita's method. Let x represent the number of cats, just like we did initially, and y the number of dogs. We're doing that too. Since cat pens require 6 square feet, 6x represents the space used by cats. Clarita is doing exactly what we did when we saw this problem. So 6x represents the space used by cats. You see that right there, 6 times x. Since dog runs require 24 square feet, 24y represents the amount of space used by the dogs, plus 24y. So my equation is 6x plus 24y is, and remember, they had 360 square feet available, 360. So that is like the inequality we created at the beginning of this activity right there. We like it. So Carlos has y equals negative 1/4 x plus 15, and Clarita is using 6x plus 24y equals 360. So now we're questioning, all right, these are equations for the same boundary line, but why do they look different? All right, so number one, since both equations represent the same information, they must be equivalent to each other. Part A, show the steps you could use to turn Clarita's equation into Carlos's equation. Explain why you can do each step. So here's Clarita's equation right here. And by the way, this equation is a linear equation, and this is called standard form right here. Standard form is a times x plus b times y is c. Now, there is more to the definition of standard form. A must be positive, so this A always has to be positive right there, and A and B cannot be fractions to be in standard form. And look at that, A is positive, A and B are not fractions. Nice job, Clarita. Now Carlos, you guys have been using this a lot, y equals mx plus b. That's slope-intercept. All right, so show the steps you could use to turn Clarita's equation into Carlos's equation. So let's take Clarita's equation. 6x plus 24y is 360. And can we take this equation and solve for the y right here? Because Carlos has y equals negative 1/4 x plus 15. Well, you guys have become experts at solving. The first thing we'd want to do, and this is solving a literal equation right here, is we need to undo this addition of 6x. So we're going to subtract 6x from both sides. Now we bring down the equals, and 6x minus 6x is gone, leaving the 24y's. And on the right, these are not like terms. I cannot combine them. So I'm going to put my x term first. So I'm going to write negative 6x plus 360. And now, one more step, we have to undo multiplication by 24. So let's divide every term in this equation by 24. Just like that. Now let's simplify each term. So on the left over here, my factors of 24 cancel, leaving my factor of y. And on the right, I have a negative over a positive is negative. And let's look at the fraction 6 over 24. Let's see. 6 goes into 24 4 times, so the factor of 6 becomes a 1, and the factor of 24 in the divisor becomes a 4. And then you still have that factor of x right there, plus, and 360 divided by 24, let's punch that out on our calculator. 360, let me clear this, 360 divided by 24, and I'm getting a 15. And let's take a look. Y equals negative 1/4 x plus 15. And Carlos's equation was y equals negative 1/4 x plus 15. There we go. 1A in the books. Okay, part B. Show the steps you could use to turn Carlos's equation into Clarita's. Explain why you do each step. Okay, so now we're going to take Carlos's equation, y equals negative 1/4 x plus 15, and we need to turn this into 6x plus 24y equals 360. Now here's the key. If I'm going from slope-intercept to standard form, I look at the standard form. I need 24 y's. Over here, I only have 1 y. So could I multiply this entire equation by 24? Let's see, 24 times y, 24y. Okay, And then if I go negative 1/4 x times 24, well, let's think. What's negative 1/4 times 24? Well, okay, look at this. Doesn't 4 go into 24 evenly? 4 goes into 24 6 times. So that's going to become a negative 1 times 6, or negative 6. And don't forget that factor of x right there. And then plus, let's multiply the 15 by 24. And I'm going to punch this out on a calculator to double check everything. So on 15 times 24, and I'm getting that 360 I was hoping for, plus 360. Now, we need to get the x and the y on the same side for standard form. So let's add 6x to both sides. Equals, and look what I have. I have 6x plus 24y. I cannot combine those. So 6x plus 24y is, and the negative 6x plus 6x cancels, and I've got 360. And there you have it. Nice. All right, number 2. Use both Carlos's and Clarita's methods to write the equation of the boundary line for the startup cost constraint. All right, well, let's start with Carlos's method. And remember, well, let's just set it up so we have something to work with here at first. So let me back off a little bit here. So startup costs. Carlos and Clarita plan to invest much of the $1,280. Now, when I see much of the $1,280, that means they can invest less than or equal to that $1,280. So there's my inequality right there. And let's get the expression on the left-hand side. They earned from their last business venture to purchase cat pens and dog runs. It will cost $32 for each cat pen, and remember, cats would be our x, so let's go at 32x, and $80 for each dog run, and we're using y for the number of dog runs, so that'd be plus 80y. So this is our inequality in standard form, and now Carlos and Clarita are looking for the equations for the boundary lines. And now Carlos did a pretty complicated method. It works. And it's a great way to really truly understand slope-intercept. You know, you see the slope in his table and the y-intercept, those things. So let's do this. Carlos's method. There's the table again, and in the first column we'll put the x for the number of cat pens that we're going to purchase, and y would be the number of dog runs that we're going to purchase, and our total cost has to be less than or equal to $1,280. All right, so let's start off simple with 0 cat pens. And if we have 0 cat pens, now take a look up here. 32 times 0 would be gone, and you're left with 80y is 1280. So to find out the number of dog runs, all Carlos would do is take this 1,280 and divide it by the 80 to isolate that y. So let me turn on my calculator and punch this out with me. 1,280 divided by 80. And Carlos would get 16 for his y. And if he plugs 16 into this equation, 80 times 16, he's going to get exactly 1,280. All right. Now, Carlos needs whole number inputs and outputs. So he probably tried a 1, a 2, a 3, and a 4 for x, but every time he worked it out, he would get a decimal for his y. But then when he got to 5 cat pens, all right, he worked that out. And he was very excited because he did this. Well, 32 times his x, 5, plus 80y is less than or equal to 1280. Now, to save time, you guys, I'd love to solve this, but we've got a lot going on here. So I'm going to show you a little shorter method to do this. If you're going to isolate this y right here, well, the first thing you'd have to do is subtract the 32 times 5 from the 1,280. And then take that difference and divide by 80. So I just did that whole thing on my calculator. So look what I did. I took the 1,280 minus the 32 times 5, and I put that in parentheses, 1,280 minus 32 times 5, and then I divided that by 80 and got a 14. And that's exactly what Carlos did. He probably showed a lot more steps. All right. Now, I know this is going to be linear again, so I'm going to look for my pattern right now. Do we see the pattern? Well, let's think about our change in y and our change in x. So the change in y. Well, it looks like our y's will continue to drop by 2, minus 2. And our x's will continue to increase by 5. 5 right there. And we'll check that later to make sure it all works. But if that pattern continues, then my next x would be 0, 5, it'd be a 10. And my next y would be 16, 14, 12. And if I plug those into this, I'm calling this an equation right now, I would get 1,280 right there. And you could keep doing that. All right. But let's go down to the bottom now. All right. Because we want to get to 0 dog runs and the maximum number of cat pens that we can purchase. All right. So again, we need to do a little bit of arithmetic here. If there are 0 dog runs, I can look right up here. 80 times 0 would be 0. And I'm left with 32x is 1280. So I've got to undo this multiplication by 32. So let's just divide that 1,280 by 32. And don't worry, we'll check all this too. 1,280 divided by 32. And there we go. So if Carlos has 0 dog runs, he will be able to afford 40 cat pens. All right. Now, the pattern is going to continue, but now we're going to go the other way. We're going to work up here. All right. So, and that's your 1,280 right there. But I bet this y right here, since from the top I'm decreasing by 2, I'm just going to add 2. All right. And up here, my x's are increasing by 5. So if I go from the bottom, I'm going to decrease by 5 and get a 35. And if I plug those into this inequality, which we're just focusing on the equation right now, I'm going to get 1280 again, I'm sure. And I'll check the last one just to make sure everything works out. So that means my next y right here would be a 4. And my next x would have to be a 30. My next y would be a 5. Oh, don't forget, yeah, plug those in, you get 1,280. My next x is a 6. Or y is a 6, excuse me. And my next x is a 25. And those plug into the equation, you're going to get 1,280 again. All right, let's check this last point right here, because if this ordered pair right here works, I can guarantee every other one has to work. So I just went to my calculator again, and I went 32 times my x, 25, plus 80 times my y, 6, and look what I got, 1,280. So this is perfect right here. And there's Carlos's method. Now, how can he come up with the equation of the boundary line just looking at this table right here? Well, first off, Carlos, y equals, all right, well, I need a slope right here, okay? And what is slope? It is rise over run. And the rise is this change in y right here, which we said already was a -2. And the run is the change in x, which we said was a 5. So the slope is -2 over 5. And then the y-intercept, the plus b right there, well, when x equals 0, y equals 16. So 16 has to be my y-intercept. And there is Carlos's equation in slope-intercept form, y equals mx plus b right here. The slope is -2/5, and the b is 16. Okay, now Clarita's method is exactly what we always do. All right, so this will be easy again. Startup costs. Carlos and Clarita plan to invest much of the 1,280, and what did we do with that? We said that means less than or equal to 1,280. Now we're doing a boundary line, so we can just call that equals to 1,280. All right. They earn from their last business venture to purchase cat pens and dog runs. It will cost 32 for each cat pen, so that'd be a 32x, plus $80 for each dog run plus 80y. And there it is. Clarita's method is a little bit easier than Carlos's, but I don't know, if you go back and look, there's a lot of learning going on right there. That's good stuff, Carlos. All right, so number 3, show the steps you could use to turn Clarita's startup cost equation into Carlos's equation. Explain why you can do each step. Okay, so again, Carlos has an equation of a boundary line to an inequality in slope-intercept form, and Clarita has an equation in standard form. And those should be equations for the same line. Therefore, we should be able to convert one to the other. So we're going to take Clarita's equation. 32x plus 80y equals 1,280. This is standard form right here. A is 32, B is 80, and C is 1,280. And if we solve for y, that would put this into slope-intercept form, and that should give us Carlos's equation. So do you see that we're just going to first subtract the 32x's from both sides and rewrite? So we have 80y, and we cannot combine my terms on the left, and I'm going to put the x term first here, negative 32x plus 1,280. And now we just divide every term by this 80 to undo multiplication by 80. Equals, so on the left the factors of 80 just canceled out, and we have a factor of y. And on the right we have negative 32 over 80, so that's going to be a negative. But then what number goes into 32 and 80? Okay, I think that's going to be negative. Doesn't 16 go into 32 2 times? And 80 5 times? Oh, look at that. And then you still have your factor of x. Plus 1,280 divided by 80. Let's punch that out on our calculator. 1,280 divided by 80. And we have our 16. And there's Carlos's y-intercept right there, 16. All right, so we just converted Clarita's equation of the boundary line that was in standard form to Carlos's equation, which is in slope-intercept form. So these are different forms of the same line. Okay, now show the steps you could use to turn Carlos's startup cost equation into Clarita's. Explain why you do each step. All right, so let's go the other way. Carlos's equation in slope-intercept, okay, we need to convert this to standard form. And the easiest way to think about this right now would be, how many y's do we need to get to Clarita's form? We need 80. All right, so with that right there, let's just multiply every term by 80. So 80 times y, 80y. And now what's negative 2/5 times 80? Yeah, you could do that on your calculator, and that would be fine. But you know what I like to do? I look at my divisor 5. Does it go into the 80? Why, yes, it does. How many times? 16 times. So I am left with negative 2 times 16, which would be negative 32. So there's my negative 32, and do not forget your factor of x right there. Plus, and then make sure you multiply this 16 by the 82. So 16 times 80. 16 times 80 is 1,280. There you go. Now we have one more step because we need our x and our y on the same side. X always has to be positive, and the coefficients for x and y cannot be fractions. So let's just add 32x to both sides. Bring down the equals and look at the left. We have 32x plus 80y. We cannot combine those. And the negative 32x and the 32x cancel and leave us our 1,280. And there's Clarita's standard form right there. In addition to writing an equation of the boundary lines, Carlos and Clarita need to graph their lines on a coordinate grid, one of the most important things we do in algebra. Carlos's equations are written in slope-intercept form. Clarita's equations are written in standard form. Both forms are ways of writing linear equations, and in fact the two most common. Both Carlos and Clarita know they only need to plot 2 points in order to graph a line, and that's the key. Lines, they're linear. So if you have 2 points, you can draw your line through the 2 points and you have the perfect graph every time. So let's take a look and see how Carlos and Clarita handled this. Number 5, Carlos's strategy. How might Carlos use his slope-intercept form, y equals negative 1/4 x plus 15, to plot 2 points on his line? Slope-intercept. This is the beauty of slope-intercept. All right? That's y equals mx plus b. All right? Where we will clearly be able to see the slope and the y-intercept. The slope is m, the y-intercept is b. So what is the slope of Carlos's line? It's this negative 1/4. And what's the y-intercept of Carlos's line? It's the b right here, 15. 15 is the y-coordinate on the y-axis, or the point where his graph will cross the y-axis. So let's plot 2 points and draw Carlos's boundary line right here. So b equals 15. Now, this is scaled by ones here, so we're going to have to count them carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right there, the y-intercept. There's 1 point. Now, let's do the slope from the y-intercept. And remember, slope is rise over run. So we're going to rise -1 and then run 4. So that means the rise is easy. We're going to drop 1 because these are scaled by 1. Now this run of 4 is a little more challenging because these hash marks on the horizontal x-axis are scaled by 3s. So you're going to have to estimate the second point for the run. So you're going to drop 1 and you're going to run 4. There's 3. So 4 would be approximately right in there. And that's the best we can do. And honestly, you know, when the lines are more complicated, slope-intercept is not quite as accurate as the method that Clarita is about to use. But if you're really careful, you can do it almost perfect. Now you take your ruler out, you set the ruler between those 2 points, and make sure it goes all the way to the x-axis, and then draw your line. And there is Carlos's graph of y equals negative 1/4 x plus 15, or the boundary line of the inequality for that constraint. Beautiful. Now let's look at Clarita's method here. Clarita's strategy. How might Clarita use her standard form, 6x plus 24y equals 360, to plot 2 points on her line? Clarita is really clever, so she looks for the 2 easiest points she can find. And you guys, I hope you have begun to understand the 2 easiest points to find given an equation are the intercepts. So 6x plus 24 equals 360. If I find the x-intercept and the y-intercept, what I like to do is a little table. Standard form means I'm going to use intercepts, and I'm going to show my intercepts on a little table. Now remember, for the y-intercept, x is 0. So I'd put a 0 right here, and for the x-intercept, my y is 0. So I'm going to go a 0 here and a 0 down here. And then I'm just going to do a little arithmetic. If x equals 0, what does this y have to equal to give me 360? So if x is 0, 6 times 0 is 0, and I'm left with 24 times what number is 360? Well, let's just find that by going 360 divided by 24. 360 divided by 24, and I have 15. So the y-intercept is 15. And now let's find the x-intercept. Y is 0. So 24 times 0 is gone, and we are left with 6 times what number is 360? Well, let's just divide the 360 by the 6, and we would get 60. There's my x-intercept. So let's plot both intercepts, the y-intercept, count them carefully again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That gets more challenging as I get older. And the x-intercept, oh, that's easy. That's labeled 60. And then get out our ruler and draw the line segment to those 2 points. And this is the graph of Clarita's boundary line. 6x plus 24y equals 360. I hope you notice they have exactly the same graph. One equation was simply in standard form, while the other equation was in slope-intercept form. And you want to be an expert at both of those. Now, carefully do your ready, set, go for 5.3, and I hope everybody has a great day.